Hey guys, we're going to be starting on page 8 in your probability yellow packet. This is Unit 5, Lesson 2, the addition rule of probability. And we're going to start with a little bit of review of our set notations for unions and intersections. And then we're going to go a little bit deeper into the applications of that addition rule that we were discovering and working with on Thursday and Friday. So first we had unions, and we said that union was the collection of any events where at least one of the collections occur. So this keyword is or. We need something from either this collection or this collection occur. So it doesn't matter where in the Venn diagram it belongs, just that something from one or the other is occurring, okay? One or the other must be true for whatever it is that we choose. And the keyword for a union is or, and the symbol is that U. The other thing that we have is the intersection, where if you're looking at a Venn diagram, that's easier to visualize because it is literally the intersection of those two circles. And the intersection is an and statement, and we use the upside down U symbol. The intersection of any collection of events is the event that all of the events occur. So and or all or both, those are all keywords. It needs to satisfy not just one, not just the other, but both of whatever these two events are on either side. Okay, sometimes that keyword and will have to be inferred from the context. And we saw that on Friday in class. It won't always say and. It might refer to both things, or they're just giving you multiple requirements that must be met. That is an and or an intersection that you're looking for. Okay? Now, the addition rule that we were talking about on Friday tells us that the probability of A or B, the union happening, is equal to A plus B, but we have to subtract the and or the intersection. So here's a visual of why this is true. If we're looking for the union, which is the whole thing, we are taking the whole left set, let's call this set A, and we're adding the whole right set. But as you can see, this intersection is being counted in both of these when we're adding them together. So we need to subtract just that intersection piece in the middle so that it's only being counted once. All right, and this is true for inclusive events. Inclusive events are two events that can occur simultaneously, and they can possibly have an overlap or an intersection. We also might come across exclusive events or mutually exclusive events, and these are things that cannot happen together. They will not have any intersection. It's like impossible for them to both be happening at the same time. It's like saying, I am in Italy, but I am also at Petmid High School. That's impossible. I'm one person. I can only be in one spot at one time. So there would be no overlap there. It could never happen at the same time. Okay? So in exclusive events, you would just simply have to add them together because there is no middle intersection to subtract. There's nothing being counted twice. That's not really going to show up too much for us. We really, really, really need to know this formula. Okay? The union equals A plus B minus its intersection. So whatever your two separate events are, we're going to add them together and subtract whatever the overlap is. All right, so let's get into page 9 and look at an example of this. Think about cars available at Gary's Auto Park. Suppose a car is selected at random from the cars from this dealership. Let the events that the car has a manual transmission be denoted by M, so that's going to be in this left circle. And let the events that the car is a sedan be denoted by S, so that is this right circle. The Venn diagram below shows the probabilities associated with 4 of the regions of this diagram. So I want to just go over that for a second because this is saying there's 4 regions, but we really only usually typically would see 3. But we also have this 0.19 that's on the outside. That is outside of any of these circles. So that represents any cars at this dealership that they're just simply not a manual or a sedan. And that could be true. We might have automatic SUVs, for example. So this represents the other cars that just are neither of these things. Okay? So the first part here is asking what is the value of the probability, that's what that P stands for, of M and S. That is the symbol for an intersection. And that's really important that you know the symbols because if you don't know what that symbol means, you're not going to know where to look on the Venn diagram. And so that intersection is usually the easiest to find, especially if we're looking at a Venn diagram because it is quite literally right in the middle. It is the intersection of those 2 circles. So that's the easy one. But in part B, now we're being asked for the union, which is the or. Okay, the or the union. So we're looking for the whole thing. And this is where that addition rule comes into play because we can't just simply add all of the numbers in the Venn diagram. And that addition rule tells us that the union is equal to one event, which is manual, plus the other event, which is sedan. But then we need to subtract that intersection so that we're not counting it in both of those separate individual pieces. Okay, so right now we are looking for the union. And now we can just plug in what we know. Okay, the probability of manual. And we need to be careful here because the probability of manual is not just 0.09, it's 0.09 plus 0.12. So I want you guys to think about that. The manual is everything in that manual circle. Okay, so take a second, figure that out, calculator, and that entire manual includes 0.3. No, it doesn't. I put that in my calculator wrong. 0.21. Okay, plus the entire sedan circle is 0.12 plus 0.6. The entire sedan circle is okay, again, I'm getting ahead of myself. This is what happens when you rush, so please learn from me. You get 0.72. And now we need to subtract the intersection, which we don't need to calculate anything for that. The intersection is just that 0.12. So take a second, guys, and now we're just putting this all in the calculator. And that will tell us the union. And you should get 0.81. So it will be an 81% chance that the car that is picked at random is either a manual or a sedan. Okay, so that is very likely.